Hello students, we are going to start a new subject, that is engineering mechanics. So the first chapter is the system of forces. In this chapter we are going to cover 2D space for 2D force system and three-dimensional force system, that is nothing but the space force system. So before starting this chapter, before going with the numericals, we are going to see what is actually mechanics is. So basically mechanics is a branch of applied science. So when we consider applied science, there is a chemistry is there is a physics is there. Okay, chemistry, physics, mathematics, biology is there. Okay, so all these are the sciences that we study. So when these sciences, or when this science is applied to our daily in a daily life, okay, then it becomes applied science that is used for human mankind. Okay, so that is nothing but the applied science. So out of that, the mechanics is one of the branch, or we can say uh, engineering mechanics. So engineering mechanics, the laws of mechanics are applied to the engineering problems and the solution is found out. So that is nothing but the engineering mechanics. So number of the engineering problems are solved with the application of science of mechanics. Basically, this science of mechanics is derived from, we can say it is derived from physics. Okay, so but it is applied in engineering problems. So it becomes engineering mechanics. So again, this engineering mechanics. So engineering mechanics is a branch of applied science, and this engineering mechanics is again subdivided into two parts. That is, one is the statics and another is dynamics. So if we consider statics, statics means a body which is in rest, which is at rest, okay, and the forces are acting on it. When we consider such situation, then we can say it is a statics. But when we consider dynamics, the body is in motion. Okay, if body is in motion, then it becomes a part of a dynamics. Okay, in case of a dynamics, again it is divided in two parts, that is kinetics and kinematics. When we consider kinetics, the body is in motion as we have already said, but we consider forces acting on it. Forces acting on it are also considered. So that becomes part of a kinetics. When we consider kinematics, the body is in motion and we only study the effect of the forces on the body. We do not study the forces. Then that part is nothing but the kinematics. So all of this definition I have written here. Applied science, that is coordinate research work for practical utility and services of the mankind, that is applied science. Engineering mechanics is nothing but the laws of and principle of mechanics which are applied to the engineering problems and the solution is found out, that is engineering mechanics. Statics means the body is at rest and all the forces are acting on it, and the effect of these forces is considered, effect of these forces on this body is considered and it is studied, that is nothing but the statics. When we consider dynamics, the body is in a motion and the forces are acting on it. Okay, so if you are going to consider the forces and the body which is in a motion, if the both of these things are considered, then it becomes part of kinetics. But when we only consider the when the body is only in a motion and the forces are acting on it, but without reference to the forces, if we only studied the body which is in a motion, then it becomes parts of kinematics. Okay, so this is all about how the engineering mechanics is subdivided and how it is applied to the engineering problems. So now we will consider the fundamental units. So fundamental units, for fundamental unit we should know what are the fundamental quantities. Okay, so if we consider the length, mass and time, these three are basic fundamental quantities. And the length, mass and the time, if we form any fundamental, if we derived any fundamental quantities from the fundamental quantities, if we derive another quantities, then it is nothing but the derived quantities. So if we consider length, so if the length, if suppose if square is there, then how we will find the area? That is nothing but the two sides of the sphere. Okay, so if we multiply this two lengths, then we will get the area of that square. So it is nothing but a derived quantity. So unit of area, if we consider the area, then there are the two lengths are involved. If we consider the velocity, then the length and time is involved, so it is again a derived quantity. If we consider acceleration, then what is the acceleration? Change in a velocity with respect to time, that is nothing but the acceleration. So again there is a velocity is there and time is there, so again it is a derived quantity. Okay, so the units of this derived quantities, they will be also varying. So if we consider SI unit system, that is international system of units, the length is measured in meter, mass is measured in kilograms, kgs, and time is measured in second. So now length, mass and time are nothing but the fundamental quantities. But in case of derived quantities, suppose these are the different derived quantities. We have here only six derived quantities, but there are number of derived quantities. So we will first see what are the derived quantities and their unit. If we consider the density is nothing but the mass upon volume. So mass is measured in a kg and volume is measured in meter cube. So kg per meter cube, it is nothing but the derived unit for the derived quantity density. Just like that, velocity is displacement upon time. Displacement is measured, displacement is nothing but the length, so it is measured in meter, and time is measured in second. So velocity is meter per second. Acceleration is a change in velocity with respect to time. So velocity is measured in meter per second and time is measured in second. So meter per second square is a derived unit of a derived quantity, acceleration. Just like that is a force is nothing but a mass into acceleration. So mass is in kg and acceleration is meter per second square. So kg meter per second square is a derived unit for the force. Okay, so kg per meter square is again expressed in Newton. Okay, so kg per meter square is nothing but the Newton. So it is simply said as a Newton. So it is a derived unit for a mass. If we consider a pressure, pressure is force upon area. Force is in Newton or kg meter per second square divided by area. Area is measured in meter square. So Newton per meter square becomes pressure. So work done is a force into displacement. Force is in a Newton and displacement is in meter. So Newton meter is a work done, and that Newton meter is again derived in Z, that is nothing but the joule. Okay, so joule is a derived unit for the work done. So these are the sum of the basic derived quantities and their units. So density in kg per meter cube, velocity in meter per second, acceleration is meter per second square, force is in Newton, that is kg meter per second square, pressure in Newton per meter square, and work done in force is nothing but a force into displacement, that is nothing but joule. So Basically, force is nothing but the mass into acceleration. But what are the effect of the forces? Force defined as an agent which produces or tend to produce, destroys or tend to destroy motion. Okay, so this is how the force is defined. Suppose if any body is in a motion and if you want to stop it, then the force has to be applied, or the energy or that agent has to be applied in direction opposite to the motion of that body. So what is the function of the force here is that the body which was in a motion, we have stopped by applying this agent, that is nothing but the force. Again, if you throw a ball, okay, so the ball was actually stationary, you have taken in your hand and you have thrown it, so you have applied a force, you have applied an agent that gave motion to that ball. Okay, so this is how the concept of the force is understood. Any body which is in motion, that can be stopped, or any object which is in stationary, that can be also moved, or to that we can apply the motion. So that is nothing but the, we can say that is nothing but the force. So classification of force system. So generally the force is shown like this. Suppose if we consider this is a certain point, and if it is the, and if the force is applied to that point, then the arrow is shown like this, and the force, it is denoted by symbol P. Okay, so this is how actually force is represented. So this is the point of application of the force, and the force is shown by arrow, and it is represented by P. So this is, we are showing the force. Okay, so classification of force system. So when we consider any object, it may be subjected to one force, or it can be subjected to number of forces. So depending on the plane in which the force is acting, depending on the direction, all of these forces in which all of these forces are acting, and the system, it forms the force of the system. If an object is there, there are a number of forces are acting, and they are acting in a different plane, they are acting in a different direction. As there are a number of the forces are there, it forms a force system. Okay, so the force system has to be classified. So when two or more number of the forces are acting on a body, it forms a force system. So coplanar force system, the forces whose line of action lie on the same plane form coplanar force system. So if we consider a certain plane and the forces are acting on it, the here the direction is not important. Okay, and they can act in any direction, but they are on the same plane, and then that kind of a system is nothing but the coplanar force system. So here we have shown F4, in total 4 forces are there, that is F1, F2, F3 and F4. Like these forces are there, but they are acting on the same plane. As the plane is same, we can say coplanar. Okay, so these forces form coplanar force system. After that, collinear force system, line, collinear. When we say collinear, co means same and line means a line. Okay, so if the forces, number of the forces, here we have shown the 3 forces, if they are acting on a same line, then they form collinear force system. Here also the direction of force is not considered. If they are acting in the same line, then it is a collinear force system. Then after that, concurrent force system. Concurrent force system. If all of the forces which are acting if they are meeting at a one point without giving consideration to their direction, if they are acting only on a one point, okay, then the force system which is formed is a nothing but the concurrent force system. The forces which meet at a one point forms concurrent force system. If we consider this, this is the point, suppose this is the point O is there, F1, F2, F3, F4, F5, F6, all of these forces are acting on that point. Some of the forces are acting towards the point and some of the forces are acting away from that point. Okay, but they are acting at the same point. Then these forces are forming concurrent force system. Okay, so it is that simple. त्याच्यानंतर आहे कोप्लेनर कॉन्करंट फोर्स सिस्टम. कोप्लेनर मीन्स दे आर ॲक्टिंग इन अ सेम प्लेन. अँड व्हॉट इज कॉन्करंट? ॲज आय हॅव ऑलरेडी टोल्ड यू, दॅट इज the forces either acting towards the point or acting away from the point, but their point of application is same. So they are concurrent but they are also acting on a same plane. Then the force system is nothing but the coplanar concurrent force system. The forces whose line of action must act at a single point and also lie on the same plane form कोप्लेनर फोर्स सिस्टम. म्हणजे एकाच प्लेनमध्ये ते काय होत आहे, फोर्स जे आहेत ते ॲक्ट होत आहेत आणि त्यांचं जे लाईन ऑफ ॲक्शन जी आहे ती एकतर त्या पॉईंटकडे पॉईंटच्या दिशेने आहे किंवा त्या पॉईंटपासून अवे फ्रॉम पॉईंट, म्हणजे पॉईंटपासून जर का दूर जात आहे परंतु एकाच प्लेनमध्ये आहेत, त्याला आपण म्हणणार कोप्लेनर कॉन्करंट फोर्स सिस्टम. कोप्लेनर नॉन कॉन्करंट फोर्स सिस्टम. नॉन कॉन्करंट फोर्स सिस्टम मीन्स the point of application of the force is not same but they are acting in a same plane. Okay, then such a type of a force system is nothing but the coplanar non-concurrent force system. आता if we consider this plane, there are F1, F2 and F3. These are the forces. They are acting on a same plane. Okay, in a same plane they are acting, but they are not directed towards a single point. Their direction of application, whether it is towards the point or whether it is away from the point, is each one is acting towards the different point. Okay, so that is they are non-concurrent. So such type of a force system is coplanar non-concurrent force system. काय आहे, एकाच प्लेनमध्ये आहेत ते, ठीक आहे, एकाच प्लेनमध्ये आहेत परंतु त्यांचा जो पॉईंट ऑफ ॲप्लिकेशन जो आहे तो पॉईंट प्रत्येकाचा वेगवेगळा आहे आणि ते कुठेही एका सेम पॉईंटवरती फोर्स अप्लाय केला जातो आहे असं वाटत नाही आहे. ते वेगवेगळ्या पॉईंटवरती अप्लाय केले जातात. फक्त ते एकच गोष्ट आहे त्याच्यामध्ये कॉमन की ते एका सेम प्लेनमध्ये आहेत. सो सच फोर्स सिस्टम इज नथिंग बट द कोप्लेनर नॉन कॉन्करंट फोर्स सिस्टम. नाउ नॉन कोप्लेनर कॉन्करंट फोर्स सिस्टम. Non-coplanar concurrent force system. So concurrent means the line of action of the forces is towards the same point. If there are three forces are there, then all of these three forces are acting towards that point, but they may be acting towards the point or may be acting away from that point. Then they are concurrent, but their plane is different. Okay, so if we consider in this diagram, so F1 is acting along this plane. Okay, on this plane F1 is acting and the point of application is this point. Okay, on this point F1 is acting. If we consider F3 and F2, they are also acting on that same point. Okay, but if we consider F2, the plane of application is this. Okay, and if we consider F3, then its plane of application is this plane. Okay, so three different planes are involved in this force system, but the point of application is same. So they are non-coplanar, means their plane is not same, but they are acting towards the common point or acting away from the common point. That is nothing but the non-coplanar concurrent force system. Okay, so दिस इज नॉन कोप्लेनर कॉन्करंट फोर्स सिस्टीम. हे जे तिन्ही जे फोर्सेस आहेत ते एका पॉईंटच्या दिशेने एका पॉईंटवरती अप्लाय करतात. त्या पॉईंटच्या दिशेने फोर्स जात असेल किंवा पॉईंटपासून दूर जात असेल, ठीक आहे, पण ते कॉन्करंट आहे ते नक्की. पण त्यांचा जो प्लेन जो आहे तो वेगवेगळा आहे. F1 एक वेगळ्या प्लेनमधून अप्लाय केला जातो आहे, F2 एक वेगळ्या प्लेनमध्ये आहे आणि F3 हा वेगळ्या प्लेनमध्ये आहे. सो दे आर फॉर्मिंग नॉन कोप्लेनर कॉन्करंट फोर्स सिस्टम. Now, non-coplanar, non-concurrent force system, okay, means they do not have a same point of application, means they are not acting towards the one common point, they are acting towards the three different points, and their plane are also three different planes. So they are non-coplanar and they are non-concurrent. So such a force system is a non-coplanar, non-concurrent force system. The forces whose line of action of the force do not meet at a single point and also lie in different plane forms non-coplanar, non-concurrent force system. ठीक आहे. सो दिस इज इझी. इफ यू कन्सिडर, आता जर का ह्याच्यामध्ये जर का आपण बघितलं तर ह्याच्यामध्ये F1, F2 अँड F3 हे तीन फोर्सेस आहेत. तर कुठल्याही एका सिंगल पॉईंटकडे अप्लाय करत नाहीत, एका सिंगल पॉईंटकडे अप्लाय केले जात नाहीत आणि त्यांचे प्लेन जे आहेत ते सुद्धा तीन आहेत, म्हणजे ते वेगवेगळे आहेत, बरोबर. तर त्यांना आपण नॉन कोप्लेनर, नॉन कॉन्करंट फोर्स सिस्टम असं म्हणू. आता पॅरलल फोर्स सिस्टम, द फोर्सेस whose line of actions are parallel to each other forms parallel force system. ह्याच्यामध्ये सुद्धा आपल्याला हे महत्त्वाचं आहे की लाईन ऑफ ॲक्शन म्हणजे काय. आता ह्याच्यामध्ये F1, F2 आणि F3 हे काय आहेत, तीन फोर्सेस आहेत, बरोबर आहे, ठीक आहे. तर त्याच्यामधून ज्या फोर्सच्या डिरेक्शनमध्ये जर का आपण एखादी लाईन जर का ड्रॉ केली, सपोज दिस इज द लाईन, ओके. सो दिस इज द लाईन ऑफ ॲक्शन. ही जी लाईन ऑफ ॲक्शन आहे, ठीक आहे. ह्या फोर्सची सुद्धा F2 जर का बघितला, जर का तो जो फोर्स आहे तो जर का अशा प्रकारे जर का आपण एखादी लाईन जर का ड्रॉ केली त्याच्यावरून, ठीक आहे, तर ही त्याची लाईन ऑफ ॲक्शन आहे. F3साठी सुद्धा ही त्याची लाईन ऑफ काय आहे, ॲक्शन आहे. आता जर का ह्यांची लाईन ऑफ ॲक्शन जर का बघितलं तिन्ही, ओके, सो दीज आर पॅरलल टू इच अदर, ओके. सो त्यामुळे जी फोर्स सिस्टीम तयार झालेली आहे तिला आपण काय म्हणतो, पॅरलल फोर्स सिस्टम, ओके. सो द लाईन ऑफ ॲक्शन आर पॅरलल टू इच अदर, बट देअर पॉईंट ऑफ ॲप्लिकेशन डेफिनेटली इफ दे आर पॅरलल देन देअर पॉईंट ऑफ ॲप्लिकेशन इज not going to be same, they are going to be different. So in this system F1, F2 and F3, the first force system F1, F2 and F3, these are parallel to each other, and they are acting in the same direction basically, okay. So in the same direction they are acting, so they are like parallel forces. And if we consider this force system, they are parallel to each other, but F1, F2 and F3 are not acting in the same direction. F1 and F2 are acting in a downward direction while F3 is acting in upward direction, okay. So they are unlike parallel forces, okay. So these are the nothing but the parallel force system in which the forces are acting parallel to each other, but they can be like forces or they can be unlike forces. Okay, so this about the parallel force system. Then after, principle of transmissibility. So this is one of the most important concept in case of a engineering mechanics. It states that as long as resultant effect of force acting on a body are not changed, the force can be applied anywhere along line of action. So if you have shown here bus, okay, there are two there is a bus, okay, which is traveling in this which is traveling in this direction like this. And suppose this is the F1 force which is applied at the back end of the force, and it's back end of this bus, and this is its line of action. Okay, so if I represent this force F1 at this point, or if I represent this force at this point, the bus is traveling in the same direction, that is, it is traveling from left to right. Okay, it is traveling from left to right. Whether I applied this force F1 at this point, or whether I apply this force F1 at this point, the effect is going to remain same. What is the effect? Is nothing but the motion of that bus, and the motion is from left to right. So the effect of this force is not altered, it is same. Okay, so the resultant effect is same, the resultant effect is not changed. As long as the resultant effect is not changed, we can show the force anywhere along the line of action of the force. That is nothing but the principle of transmissibility. काय ह्याच्यामध्ये एक बस आहे, ठीक आहे, या बसवरती हा F1 हा फोर्स जो आहे तो ॲक्ट होतो आहे, आणि ही त्याची काय आहे, लाईन ऑफ ॲक्शन आहे. हा जर फोर्स आहे जो मी ह्या पॉईंटला जरीसुद्धा दाखवला F1, किंवा मी ह्या पॉईंटला दाखवला, तरीसुद्धा त्याचा जो काही इफेक्ट जो आहे तो चेंज नाही होणार. आता इफेक्ट काय ह्या फोर्सचा, तर तुमची जी बस आहे ती डावीकडून उजवीकडे चालले. मी फोर्स इथे अप्लाय केला तरीसुद्धा बस डावीकडून उजवीकडे जाईल. मी फोर्स जर का इथे अप्लाय केला तरीसुद्धा बस डावीकडून उजवीकडे जाईल. म्हणजे अलॉंग द लाईन ऑफ ॲक्शन मी कुठेही जर का फोर्स दाखवत असेल तर त्याचा इफेक्ट जो आहे तो जो आहे तो काही चेंज होत नाही आहे. तर त्याला आपण म्हणतो प्रिन्सिपल ऑफ ट्रान्समिसिबिलिटी. म्हणजे तो म्हणजेच काय, प्रिन्सिपल काय आहे याच्यामध्ये, की अलॉंग द लाईन ऑफ ॲक्शन तुम्ही फोर्स कुठेही तिथे दाखवू शकता, फक्त प्रोव्हायडेड दॅट की त्याचा जो इफेक्ट आहे त्या बॉडीवरती किंवा त्या ऑब्जेक्टवरती तो चेंज नाही झाला पाहिजे. ठीक आहे, जर हा आहे प्रिन्सिपल ऑफ ट्रान्समिसिबिलिटी ज्यावेळेस आपण वापरतो, so the force can be treated as a sliding vector and we need to specify only the magnitude and direction and line of action of the force. ओके, तुम्ही जो फोर्स हा जो फोर्स आहे तो त्या बॉडीवरती अलॉंग द लाईन ऑफ ॲक्शन तुम्ही जो आहे तो फोर्स जो आहे तो कुठेही दाखवू शकता. ओके, याच्यामध्ये फक्त आपल्याला काय दाखवायला पाहिजे, मॅग्निट्यूड दाखवली पाहिजे, डिरेक्शन आणि लाईन ऑफ ॲक्शन ऑफ अ फोर्स दाखवली पाहिजे. बरोबर आहे. सो दिस इज ऑल अबाउट द प्रिन्सिपल ऑफ ट्रान्समिसिबिलिटी. बेसिकली काय आहे, तुमचा जो फोर्स आहे अलॉंग लाईन ऑफ ॲक्शन तुम्ही कुठेही दाखवू शकता, ॲज लॉंग ॲज त्याचा जो इफेक्ट आहे तुमच्या ज्या बॉडीवरती होणारा तो चेंज नाही झाला पाहिजे. ठीक आहे, तर हे काय आहे, प्रिन्सिपल ऑफ ट्रान्समिसिबिलिटी आहे. ओके, देन